Most know the white cane as a simple but crucial tool that assists people with visual impairments in making their way through the world. Researchers at Stanford University have now introduced an affordable robotic cane that guides people with visual impairments safely and efficiently through their environments. Using tools from autonomous vehicles, the research team has built the augmented cane, which helps people detect and identify obstacles, move easily around those objects, and follow routes both indoors and out. The augmented cane is not the first smart cane. Research sensor canes can be heavy and expensive, weighing up to 50 pounds with a cost of around $6,000. Currently available sensor canes are technologically limited, only detecting objects right in front of the user. The augmented cane sports cutting-edge sensors weighing only 3 pounds, can be built at home from off-the-shelf parts and free open-source software, and costs $400. The researchers hope their device will be an affordable and useful option for the more than 250 million people with impaired vision worldwide. The researchers published a paper describing the augmented cane in the journal Science Robotics. The paper comes with a downloadable parts list and DIY solder at home instructions. The augmented cane is equipped with a LiDAR sensor. LiDAR is the laser-based technology used in some self-driving cars and aircraft that measures the distance to nearby obstacles. The cane has additional sensors including GPS, accelerometers, magnetometers, and gyroscopes like those on a smartphone that monitor the user's position, speed, direction, and so forth. The cane makes decisions using artificial intelligence based wayfinding and robotics algorithms like simultaneous localization and mapping, and visual servoing, steering the user toward an object in an image. Mounted at the tip of the cane is the piece de resistance, a motorized omnidirectional wheel that maintains contact with the ground. This wheel leads the user with impaired vision by gently tugging and nudging left and right around impediments. Equipped with built-in GPS and mapping capabilities, the augmented cane can even guide its user to precise locations like a favorite store in the mall or a local coffee shop. In real-world tests with users that volunteered through the Palo Alto Vista Center for the Blind and Visually Impaired, the researchers put the augmented cane in the hands of people with visual impairments as well as sighted people who were blindfolded. They were then asked to complete everyday navigation challenges, walking hallways, avoiding obstacles, and traversing outdoor waypoints. In that regard, the augmented cane excelled. It increased the walking speed for participants with impaired vision by roughly 20% over the white cane alone. For sighted people wearing blindfolds, the results were more impressive, increasing their speed by more than a third. An increased walking speed is related to better quality of life, so the hope is that the device could improve the quality of life of its users. The scholars are open sourcing every aspect of the project. Anyone can go and download all the code, bill of materials, and electronic schematics all for free. But the cane is still a research prototype. Next steps for the team include refinements to their prototype and developing a model that uses an everyday smartphone as the processor, and advanced that could improve functionality, broaden access to the technology, and further drive down costs.